Okay, I'll explain this one part again. For example, now, let's say you have these two plates. These plates, they are very close to each other here. You can see here, these two plates. And let's say under these plates, you have a lava. Let's say this is the lava or magma. When temperature becomes really high, this lava rises. When this lava rises, it applies a pressure on the plates. When it applies the pressure on the plates, so here it will not find the way to go out. Only the soft place for them to go out is the boundary where the plate meet with each other. This is the place from where they can go out. When this lava go out, so these plates, they move away from each other. They move away from, then the lava come out. So if this condition in which lava comes out and plates move away from each other, as you can see in this diagram, from here lava comes and it's break up and the plates, both plates are moving in different directions, this side and this side. So this type of boundary, this boundary is known as constructive plate boundary. Constructive plate boundary. Once again, when the lava comes out, because this is the only soft place through the lava can come out, so it moves the plate away from each other in sideways. So that is known as, this boundary is known as constructive plate boundaries. Any confusion? Okay. Now we talk about this one. Where the convection current sinks, the plate move towards each other. Okay. Now another. For example, now these are two plates. Now here under this one also you have lava or magma. If it will go down, in other words, you can say that this lava, before it was here, now this level will come down here. What will happen? These plates also come down. What will happen? One plate will be up on other and other will be down like this. Because lava is going down, so this plate also going down. So what will happen is, you can see this one plate, it is going down, other plate come over it. Okay. So where the convection current sink, mean this hot liquid, it go a little bit down, the plates move towards each other. Like this you can see. So what will happen? One plate become down like this and other plate will come over it like this. So this is the another type of the boundary, and this boundary is known as plate margin, like this, plate margin, this one. Now movement of plates. Now the plates under the earth, the tectonic plate, they can move in three ways. They can move in three ways. Number one, when they move away from each other, you can see this is going to this side, this is going to this side. So they are moving away from each other. The motion direction is when they move towards each other. Third one, when they slide with each other. One is going this direction, other is going to this direction. So it means they are sliding. Okay. So if it happens like this, so this is known as divergence. If something going away from each other, so it means known as zone of, this area is known as zone of divergence, this one. And if they are coming towards each other, so this is known as convergence. And if they slide over each other like this, so this is known as transform fault. This fault, this line is known as transform fault. In physics, you are doing the lens. In the lens, you have two types: converging lens, diverging lens. Got it? Converging lens means this is the lens, light coming like this in the lens, and it will make them on one point, all of them. It means it is converging. Converging means bring the different things on one point. And diverging means if this is the lens, if the rays are coming, after punch this lens, they move away from each other. So this is known as diverging. So here you can say this is diverging, they are moving away from each other. This is converging, they're moving towards each other. So like this, the plate moves, and also plate moves like this. That's known as transform. So first of all, you should understand how the plates can move. They can move away from each other, they can move towards each other, and they can move in a sliding each other to each other. So that is three type of the motion of the plates. Now we'll see in more detail. Now these plate boundaries, which plate boundaries? These ones. This is also plate boundary. Plate boundary mean where two plates meeting each other. So this is known as plate boundary, this part. Here they meet each other, also known as plate boundary. Here also they meet or slide each other, that's also known as plate boundary. So now you can divide these plate boundaries into three categories. What are they? We'll see now. Number one, you have constructive, divergent. Other, you have destructive, convergent. After that, you have conservative. We will see all of them. Don't worry. From the name, maybe it's a little bit difficult, you can feel, but it's easy. First of all, we see that constructive divergent plate boundary. What is that? When two plates move away from each other, when two oceanic plates move away, a gap or weakness is formed and magma rise to the surface. See here. So these are two plates. One plate, this which one plates? This is North American plate, and this is Eurasian plate. They are moving away from each other. When they move away from each other, so there is a small gap comes, and from here the lava comes out. So this small gap is known as volcanic vent, mean the place from come out. So this thing is known as constructive or divergent plate. You can say constructive plate, or you can say divergent plate. You can say any name. So once again, when two plates, they are moving from each other, moving away from each other, there is a small weak area comes through this, the lava comes out. So this type of the boundary is known as constructive or divergent plate at that time. You can see here also, these two plates, they're moving away from each other, and from here lava can come out. These I just added for you. This is not, you can say you have to memorize everything. Just I explain this one. Now they can also form shield or basic volcano and have non-explosive eruption. This is known as seafloor spreading or ridge push. See here. What does it mean? It means that if you see this one, so here, when the lava comes out, if it is under the sea, for example, this is a hot rock, and you can see here, this is coming out from this one. And it remains inside the ocean. It doesn't come out. For example, here, so you can find that it convert again into a like a bed or sea floor, because you have two things. Now see, if the lava come out, that's known as volcanic activity. If the lava will not come out and it remains near the sea surface, so it make a just like a bed, and that is known as sea floor. Now, whenever it happens, whenever the plates they move away from each other and the lava come out or lava will not come out, there are two possibilities. Either lava will come out or lava will not come out. So earthquake happens whenever the plates disturb, plate move away from each other. So you will get the small earthquakes are triggered. Triggered means started. If two continental plates move away from each other, a rift valley form. This is the rift valley. Maybe you saw it in the real also, but as an animation, it's look like this. These are two plates, and in between, this is a like a down. This level is down. I will show you in the real diagram like this. Between two, you can say mountain. This is the area. This area is known as Raft Valley, which is down area. Why? Because this plate move away from this plate and this gap is produced. So that is known as Rift Valley. After that, destructive or converging. Again, what was the first one? Constructive and divergent. Constructive and divergent. Divergent means move away from each other. Diverge. And now other one is what? Destructive and converging. Converging means brings towards each other. They're saying when two plates move towards each other, so it is known as destructive converging. So sometime they can ask, they can say only destructive plate boundary. They can say also converging plate boundary. So both are the same thing. When it happens when two plates come near to each other? When an oceanic plate and continental plate move towards each other, denser oceanic plate is forced down under the lighter continental plate. Let's see here. Let's say this is the plate. Which plate this is? Let's say this is oceanic plate. And this plate is known as continental plate. Now this plate is dense. Dense means heavier than this one. When they move towards each other, so the dense one, it will come down. So this oceanic will come down, and above this one, you will find the continental. It goes like this. When an oceanic plate and continental plate move towards each other, the denser oceanic plate forced down under the lighter continental plate. You can see here the diagram. See here. Understand? So this is the oceanic crust, the oceanic part, and this is the plate. It goes down, and above this one, which comes continental. Why? Because oceanic is more dense, so it goes down. So this is known as destructive converging boundary. Whenever the boundary comes like this, I'll show you the real diagram. Again, see here. This is the oceanic, it goes down, and this continental plate come up. In real life, how it look like, see here, this one. If you will find this kind of structure in a rock, it means it happens to destructive converging plate boundaries. You can see here, and again they have given the example. Now they use a word that oceanic island. It means that whenever in the ocean, you will find these volcanic activities or plates are moving over each other, so you will get new islands. Okay, you known as new island, and these island in the sequence they are known as back arc rift. Means you can see they are just like in an arc form. So this is known as back arc lift. What is back arc lift? Again, I'm saying that when two plates, one is oceanic plate, other is continental plate. Continental means the dry land. When they come near to each other, oceanic is more dense. So it comes down, and above this one, what will come? Continental. So when it happens, you on the surface, you will find this type of structures. The small rocks come out of the water. If the rocks will come out in this pattern from the water, so that is known as back arc lift. You can see that other diagram also, they are doing the same thing here. This is okay. After that, you have another picture, the same destructive converging. This plate, you can see it is going down. Which plate? This is oceanic. Again, why it's going down? Because less dense. And when the lava comes out from here, so you are getting these type of the rocks that is known as volcanic arc. After that, you have conservative plate boundaries. If you remember, we said that if the plates are moving in this direction, they are sliding over each other, they're sliding each other in from sideways. So this is known as conservative plate boundaries. Okay, and this motion is known as transform motion of that one. So what is this? We'll see now. Conservative plate boundaries. Two plates slide each other, slide past each other. They move in different speeds. The plates get locked together and pressure build up until it is released as an earthquake. You know, sometimes these plates, let's say this is one plate. Then this is another plate. Now, when they slide with each other, let's say I will draw a diagram here. Now, these plates, they stuck with each other. It want to go this side, it want to go this side, but due to this unsmooth surface, they stuck with each other. Still, the magma is applying a force to move them. But if they stuck, then earthquake will come, and then they go away from each other because pressure will be from down, they move away from each other. So only thing you can move them away from each other if they stuck, that is the earthquake, and due to this earthquake comes. The magnitude of an earthquake is measured using, this is a seismometer and that Richter scale. These are two scales are used, that seismometer or Richter scale. Maybe you heard this one a lot, that earthquake was 7.4 at Richter scale. We'll see that what are these scales. So these are the three boundaries we have studied till now. Number one, we start about constructive. After that, we studied about destructive. The third one we talk about conservation. This is known as also divergent. This is also known as convergent. This one, and this is the third. 1, 2, 3. So here we have studied 3 types of the boundaries. Okay. Once again, what is constructive? The plates move away from each other. That's known as constructive. Destructive means plate come over each other. Number 3, they slide with each other. So these are the boundaries, 3 types. You can see this one here. They are moving. One is moving this side, other is moving this side. You in the real diagram, you can see them like this. See, this is conservative. How you have these. Now, characteristics of an earthquake. Whenever talking about the earthquake, so what is the earthquake? When the earth shakes. And why earth shakes? Because under the earth, tectonic plates, they move. When the tectonic plate moves, not all the time they are moving. Sometime only they move, adjust themselves due to high pressure or due to any reason. So then earthquake comes. So now here they're saying that earthquake is when the ground shakes in sudden jerks. It results from a building up and sudden release of tension. Because under the plates, if there is a high amount of heat and pressure, then the magma come out, then earthquake comes. Occurs mostly in destructive and constructive plates. So where it happens more, destructive or conservative, sorry. Destructive and conservative. Destructive means they slide over each other. Conservative means they move like slide, means they move by sliding over each other. So this is known as the characteristic of the earthquake. Now there are some terms are used in the earthquake. Really easy. Number 1 is the focus. The first thing is known as the focus. What is the focus? Now we know that earthquake comes due to the movement of tectonic plates. And those tectonic plates are where? Under the ground. So it means earthquake always comes from the under the ground, the tectonic plates. Now from where it started, the place where the earthquake started, that is known as focus. For example, here the plates are moving from each other or coming over each other. So this is area known as, this point is known as focus. And sometimes it also known as hypocenter. If you go just above, for example, here you have the focus. If you go just above here, but outside the earth, mean the ground, so that is known as epicenter. That's known as epicenter. Once again, the point where the earthquake has started, for example, this point, this is known as focus or hypocenter. Got it? And just above that point, outside the ground, so that point is known as epicenter. So this is the main 2 things you should know. Number 1 here, what is the focus? When the earthquake begins under the ground. Number 2, what is the epicenter? The point on the surface above the focus. That's known as epicenter. Now, see here. Let's say here is the focus of the earthquake. this part. This is the focus. Just above this one here, what you have? Epicenter. Got it? The earthquake moved from one place to another in all direction. This. So in the form of seismic waves, earthquake moves from this point focus to other side in the form of what? Seismic waves. These are the type of the waves. Now the earthquake near this area, for example, this is the epicenter. This near this area, earthquake is very strong. As you go away from it, the earthquake become less, the magnitude become less, and when it's come out, it be also less as compared to in the center. So the same thing they are saying that, for example, if this is the earth and here is the focus and other focus is here, for example, this is A, this is B, here it is the focus and also this is focus, two focus A and B, and you are here. So by which you will feel more earthquake? Which focus is near to you? This focus is near to you, so you will feel more jerks or more movement of the earth as compared to this one, because it is far away from the, you can say, surface. So once again, whenever they are talking about the the focus mean the point from where it is started. After that, the line, one line pass through this focus and go like this. That is known as fault line, known as fault line. And the point just above the focus on the ground is known as epicenter. And the earthquake moves from one place to another in the form of seismic waves. So these are the three things you should remember. After that, the magnitude of earthquake, it can be measured by the Richter scale. Okay, it is a seismograph. You can see here this one. Now this is the pendulum. Let's say I will make it for you. Now here is a pendulum. Pendulum means this can move. When this thing move, it can move easily. If you want to move this thing, it will also move. It's with a thread. What they will do, they will add a pencil here under this one. Understand? And then they have a drum. This drum rotates. This is a drum and it has a paper on it, like this you can see here. So when the earth, this is rotate. When earthquake comes, so this move in this direction, this and this direction, and this one rotates. So it is, this pen is writing like this. You see, this is the pen and this is drum is moving and this is on the drum. So when it moves, like, why it moving? Because this support is moving like this. When earthquake comes, so this move like this direction. So due to that, this ball will move this one, this one. So when it will move in this direction, it will go like this. When it will move this direction, it will go like this. So in these are the ways how they are finding the graph, and then they use this graph to find the magnitude of this one. There is another, this is the real diagram of this one. Okay, now you can see this pen which is used here, this move this direction and this direction. So then it is making like this, and this drum is rotate in this direction, rotating. So when it's rotating, so pen is here, so it's moving like this. So this is known as Richter scale, and it is used to measure the earthquake. You can see here also, this is the same thing. Now, during the earthquake, the faults are produced. Whenever there is an earthquake, the fault will be produced or the cracks will come on the earth's surface. And when it comes like this, the earth's surface become weak. You can see here. This is before the earthquake. You can see the soil particle, they are very close to each other. When the soil particle very close to each other, so this soil is known as strong, very strong. But see, after the earthquake, what happens? You can see the gaps. They are away from each other as compared to this one. When they have a gaps, your soil become weak, and it's become so weak the building will go down in the soil. They cannot stay. So this is how the building will fall during the earthquake, because the ground becomes soft and they go down. This one, number one. Secondly, due to the movement of the plates, when they move right and left, the building also fall down. You can see here, after the earthquake, you can see this is divided. There is a fault or there is a break on the earth's surface. Tsunami. What is tsunami? Tsunami, now one is we have earthquake. We just studied now the earthquake. Tsunami is an earthquake under the water, in the ocean. Tsunami is an earthquake under the water, and when there is an earthquake under the water, this water moves very high. And when it moves very high, it comes out of the sea like a flood, and all the nearby coastal areas, they go under the water. So that's known as tsunami. You can see here another example. This is the, you can say, somewhere here, the, let's say, center or the focus of earthquake. Above the ground, you have what? Epicenter. Got it? When there is an earthquake under the water, so water level will increase and it produce a storm in the water, and that water become really high, the waves, and will come over all this dry area. So that is known as tsunami. See now, the tsunami start during the earthquake inside the sea. Now, factors that affect the impact of the earthquake. How much, you can say, loss will happen due to earthquake? It depends on location of the epicenter. For example, this is the ground, earth, and down here, earth, here you have what? Focus. Means from where earthquake start. Just above this one, you have here epicenter. Then question comes, how it will decide? For example, if here you have rocks, you have hill area, then this is very strong. It means that there will be no more damage because the land is already really hard here. But if above the focus, this area, let's say here is the focus, and this area is like you can say seaside, this area like a seaside here, the land is already soft, and when the earthquake will come, it's make it more soft and the building will fall down. So they're saying that location of epicenter it decides that how much loss the earthquake will make. After that time of the earthquake, mean if the earthquake will come for 4 seconds and another earthquake comes for 10 seconds, which is more dangerous, 10 seconds. How long the earthquake will remain, more the effects it will produce. After that, the next point, which will decide how the earthquake will happen, geology area, mean that area. If that area, the soil is soft, more loss. After that, relief of the area means people can reach there easily. For example, this is the area, it has a river, and over the river you have a bridge, and then again the land start. Let's say earthquake came in this area, and due to earthquake this bridge, it has broken, so people cannot reach here due to the bridge is not there. So then people cannot get relief, people cannot reach here to help the other people, mean the government, the fire difal madni, fire brigades, ambulance, they cannot reach to this area, they cannot do the relief work. If it happens like this, so here the situation will be more dangerous, people can die more than if the relief will come here, less people will die. If the doctors and the other people cannot reach there, they cannot give relief, it means more the loss will happen. After that, severity of the earthquake, sorry, aftershocks. What is an aftershock? For example, now this is the plate, they move over each other. Let's say this plate come over each other, this one, like this. Now normal position of this plate is this one. When it move up, earthquake came and it become like this. After some time, again this plate will move away from each other. Before they came closer and become like this. After some time, they start to move away from each other, but slowly. When they move slowly away from each other, again earthquake comes. But that earthquake which comes during the settlement, that is, you can say, less than the original earthquake. So this earthquake which comes when they are settling, that's known as aftershocks. After that, it depends on the level of development, the human settlement. You know that the most earthquake comes in Japan. But now the Japan, they are making the building that is earthquake proof. Mean if even the earthquake comes, there's no, you can say, loss. So if you are living a country in which the buildings are designed in such a way that earthquake will not damage them more, so that will be less loss in that area. How many people are living there? More people die, then it's more. Building strength, as I told you, the building in that area is strong or not,